Welcome back, students. We'll be looking at section 9.1, practice problems for introductions to relations and functions. They want us to give the domain and the range and determine if the problem is in fact a function. So remember, your domain is the x value, your range is the y value, and then we need to determine if it's a function. So looking at number 1, my x values, I'm going to list them least to greatest, and don't forget you need your little squigglies, your little braces here. So we're going to go -12, -10, 8, and then the little brace. For our range, we have, let's see, 3, 5. I'm not going to repeat the 3 because remember, we only write the number one time if it's there twice. All right, so determine if this is a function or not. So remember, the important part that we always look at is whether or not the x repeats, okay? If x repeats, not a function. Let me put this in proper grammar here. If x repeats, then it's not a function. That's what we learned in our notes. All right, so do any of our x values repeat? No. So this is in fact a function. Number 2, our values for our domain are -3, that's the lowest, and then we have 2 9s, so we're only going to write it one time, okay? Now we're going to do our range. I have a -2, a 1, and a 5, and we need to have our braces. Now we need to figure out if it's a function. So again, we have to look and see, do any of our x values repeat? Yes, the 9 repeats, so this is not a function. Number 3, domain, we have 3 is our lowest, I believe. And then we have 5, then 8, then 9. Our range, we have 0, 3, 4, and 9. All right, do any of our x values repeat? No, so if this is a function. Number 4. All right, they've changed up the way that our coordinates are demonstrated, but we still list them in the same way. We still determine if it's a function in the same way. So the domain, remember, is our x values. So our x values are -7, 0, 5. And our range is -2, 0, 1. Did any of our x values repeat? No, they didn't. So this is a function. Number 5, our domain is, just a 4, because we don't list it multiple times. We only list it the one time that we see it. All right, range is going to be -1, 0, 3. Do any of our x values repeat? Yes, we only have one x value that's attached to all of those y values. It's the 4. We actually have it 3 times. So this is not a function. Number 6, our domain is -4, 2, 4. Our range is just 3. All right, so do any of our x values repeat? No, they don't. So this is, in fact, a function. Number 7. Now instead of a table, we have the bubbles. I'm going to go ahead and label them. This is x. This is y, always. So let's go ahead and label all 3 of these. Oop. I didn't change my color here. So x, X, and then Y, Y. All right, so number 7, our domain is going to be 0, 2, 5. My range is -6, -3, 4. Yeah, in that order. All right, so I need to determine if this is a function. When we have the bubbles, we have to look at the arrows. I notice that I have a 5 to a 4, and I have a 2 to a 4. So the 4 is attached to 2 x's. That's not what we need to look for. It doesn't matter if the 4 repeats. It doesn't matter if the y, it doesn't matter if the y repeats. It doesn't matter if the y is attached to 2 x's. What matters is if the x repeats, if the x is attached to 2 y's. So I do see a problem though that demonstrates what I just mentioned. So this 2 here, it's attached to -6. It's also attached to that 4. So that 2, that x value is repeated. It has 2 y values. And I'll write it out in coordinate form so you can see it. 2, -6. That's one of the coordinates. And then 2, 4 is the other coordinate. Our 2 is repeating basically. So this is not a function. So if your x value is connected to 2 y values from one number here, like this, that is not a function. All right, number 8. The domain is 0 to 9. Our range is going to be -3, -1, 3. And is this a function? Well, do any of our x's have arrows to more than one number? No, they all have just one arrow. So this is a function. Next one. Our domain, we have -1, 0, 2. Our range is 0, 3. Do any of our x's have more than one arrow attached to it? No, they all only have a single arrow. So this is a function. Number 10. Now we're going to look at graphs to figure out if it's a function and also to figure out our domain and range based on the image on the graph. All right, so remember the domain is our left to right. The range is our up and down. So the domain of this particular line, does it ever end going left or right? No, it's going infinitely in both directions. So the way we'd write our domain is -infinity, infinity, and then parentheses. What about our range? Does it ever stop going up and down? No. So it's the same. It's -infinity to infinity. Now we've got to determine if it's a function. So remember we learned that we use the vertical line test. If I draw a vertical line down, am I going to hit this line in more than one location for each vertical line test? No, I'm only going to hit it in one location each time I do it. So this is a function. All right, number 11. So remember, our domain is left to right, and our range is up or down. I'll go ahead and draw that on all of these so that we have that. So up and down, and then our domain is left to right. And I would recommend you do this too, just to help you keep it straight what you're looking at. All right, so the domain for number 11, does it ever stop going left and right? No, it goes on infinitely. So -infinity to infinity. Our range, does it ever stop going up or down? Yeah, we've got a zero slope here. It doesn't go up and down. It only has one value. And that value is where it is on that y-axis. And it's at -2. So our value for this one is -2. Now we've got to determine if it's a function or not. If I do my vertical line test, am I going to hit that line in more than one location at any point when I do that vertical line test? No. So this is a function. Number 12. Looking at our line, does it go left and right? No, it only has one location on our x-axis. It has a location of 4. So our domain is just 4. What about our range? Does it ever stop going up and down? No, these are infinite. So -infinity to +infinity. Is it a function? Well, if I do my vertical line test, look at that. I hit that whole line. So this is not a function. No. Number 13. Our domain from left to right. Does it ever stop? Nope. It constantly goes left and right. So -infinity to +infinity. Our range, does it ever stop going up and down? No. So -infinity to +infinity. Let's see, is it a function? So let's do our vertical line test. Am I going to hit this line in more than one location no matter how many times I do this vertical line test? No. So this is a function. Number 14, our domain. This is a shape. So we need to think about, are there any limits to our shape? Does it ever stop going left and right? Yeah, it does. It actually stops at -3 and +3. These are our limits for left to right. It lands on those numbers, so those numbers are included in our solutions. So the way we're going to write this is bracket -3 to +3 bracket. Well, what about our range? Is there any limit to how high or low we go? Yes. We've got -5 and 5. And again, it includes those values because it's on those values. So I'm going to say bracket -5, 5, bracket. Now we've got to determine if it's a function. If I do my vertical line test, look at that. I hit that shape in more than one location when I do that vertical line test. So this is not a function. All right, let's look at our domain for the next one. Does it ever stop going left or right? It looks like it does, but it doesn't. It gradually gets wider as it's going. It's just so slight that it's hard to tell. But it is -infinity to +infinity. Well, what about the range? Do we have any limits to our range? We do have a limit to how low it goes. It doesn't go any lower than -3. But it goes all the way to +infinity for how high it goes. Is this a function or not? I almost forgot to answer that question. Well, let's see. If we do our vertical line test, am I going to hit this in more than one location at a time? It looks like we might in some locations, but no, we wouldn't. So this is a function. Number 16, our domain. Let's go ahead and do our little diagram arrows just to kind of help us. Okay. All right, so our domain is left to right. Are there any limits? Yes, it doesn't go past -4 here. It includes -4, but doesn't go past it. So bracket -4, and then to the right, it goes infinitely. So we have +infinity. What about our range? Even though it looks like it's not getting any higher, it is. It's just like in the previous one, it's so gradual, it's hard to see. But it is getting wider gradually. So this one is -infinity to +infinity. What about the function? If I do my vertical line test, Oh, I hit in 2 locations with 1 vertical line test. So this is not a function. Number 17, our domain. Does it stop getting any wider left to right? It does. It actually has a limit of 2 and looks like 5. So our brackets are going to be 2, 5. It doesn't go past there. Now, what about our range? Yeah, actually, we have a limit. Let's see. We have 5, and then we have 1. So we're going to have bracket 1 to 5 here. All right, is it a function? Well, if I do my vertical line test, I'm going to only hit in 1 location at a time. So yeah, it's a function. Number 18, our domain is our x value. Do we have any limits? Well, let's see here. It's going -3, and then we got that shaded area over there. So all that's part of our solutions as well. But the -3 is not included because this is a dotted line. So I'm going to have a parentheses, -3, comma, positive infinity. What about my range? Does it ever stop going up and down? No. So that one is -infinity to positive infinity. Is this a function? Well, let's test it. Let's see. If I do my vertical line test, guess what? This is not a function because that whole shaded area is the solution set. And so when I do my vertical line, I'm basically hitting an infinite number of solutions through that shaded area. So this is not a function. All right, let's look at our last few, and that involves the equations, determining whether or not this is a function based solely on equations with no graph or charts or tables. So number 19 has y equals 3x plus 7. Remember I told you that as long as your y has a exponent of 1, nothing higher, and you also have an equal sign, then it should be a function. You'll also have, for your domain, a -infinity to a positive infinity. It doesn't matter what you put in for your x, you will always get a unique y. So there's no limits to what we can put in this equation. And it is, in fact, a function. Number 20, I have y equals x squared plus 5. Uh-oh, I see x with an x squared. Oh, wait. We talked about this. It's not if the x has a squaring to it. It's if the y does. The y doesn't. It's still y to the power of 1. So we're good there. And we have an equal sign. It's not an inequality. So we're good there. So this is, in fact, a function. But now we need to figure out our domain and our range. Our domain, doesn't matter what we put in our x, we're going to end up with a unique y. So that's going to be a -infinity, positive infinity. Our range, however, because of that x squared, our range, our y values will always be positive in our answer. So this one is going to have the bracket 0, comma, positive infinity. And it's all because of this x squared. Number 21, y squared equals x minus 2. Here we have that y squared. This is the problem. So I know automatically this is not a function. But we still need to figure out our domain. Now, our x will always be a positive number in this situation. So now we're going to use the bracket 0, positive infinity for our domain. And our range will be -infinity to positive infinity. So they're the opposite of each other. Number 22, y equals 6 over x plus 3. All right, so remember in our notes, we learned that we can't have a 0 in the fraction denominator. So we need to figure out what number would give us a 0 in that bottom. So I'm going to write out y equals 6 over x plus 3. If I replace that x with a -3, then I end up with a 0 in that denominator, and that's not allowed. So what that tells me is -3 cannot be a part of our solution. So the way we're going to write our domain is from -infinity all the way as close as possible as we can get to -3, but not including -3. That's why I have a parentheses. United with parentheses -3. Every number to the right of -3, but not including -3, to positive infinity is included in the solution. So this is telling the person that reads this, every number is a part of the solution except for -3. Now let's talk about our range. There's no limit to our range in this situation, so we can put -infinity to positive infinity. Is this a function? For every x, will we have a unique y? Yes. Number 23, we have another fraction, y equals x minus 6 over 3. But this is a different situation. We're not going to end up with a 0 in the denominator. We don't have anything but a 3 down here. So we don't have to worry about what we did in number 22. All we have to think about is, for every unique x, will we have a unique y? And yes, we will. So I'm going to put -infinity to positive infinity for both of these. Now we need to think about, is this a function? Well, we don't have a y squared, we don't have an inequality, and for every unique x, we'll have a unique y. So yes, it is a function. Number 24, we have y is less than 4x minus 4. So let's think about our domain. Are there any limits to what we can put in for x to get a unique y? No, it's infinite. So -infinity to positive infinity. We have the same thing for our range. There's no limit. Now we need to think about if it's a function. Does it have y with a higher than a 1 exponent? No, we have a y with an exponent of 1. Do we have an equal sign? No, we have an inequality. There's the problem. We have the inequality here. So that means this is not a function for this particular problem. All right, let's read our quote. Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. William Paul Thurston. All right, you guys, I hope you're having a great day. I'll see you in the next video. Bye.